Hello guys, today we're doing LeetCode question 350, intersection of two arrays 2. The question is, given two integer arrays nums1 and nums2, return an array of their intersections, which means elements that are the same. Each element in the result must appear as many times as is shown in both arrays, and you may return the result in any order. So example 1, nums1 is an array of 1, 2, 2 and 1, nums2 is an array of 2 and 2. So the output is 2 and 2 as an array because 2 appears twice in both elements, and 1 doesn't appear, so it's removed. So nums1 is equal to 4, 9 and 5, nums2 is equal to 9, 4, 9, 8, 4. Now the output is 4 and 9 because 4 appears once in each array and 9 appears once in each array. You can also return 9 and 4 as you can return any order. So if you've done the first part, so let's LeetCode 349, intersection of two arrays part 1, it's very similar, except we were using two sets before. Now we don't use any sets, we use a map and an array. A map to store the key of the value as the key, and the amount of times that we have occurred in that value as a value. And we count if the value is more than 1 as we decrement. So we loop through both arrays, we count the times the number occurs, and then we decrement at the time the number occurs for the next array. And every time we decrement, if it exists, we also add it to the resulting array. So let me show you how we do it here. Okay, so the first thing we do is we create a map to store our keys as the value we come across. So the value that we come across is a key, and each time we come across it is the value. So we have an empty map. And we also have an array, or we still call it as a result array, to store the numbers we come across in both arrays. So we start by looping through nums1, so we come across 1. We check if that value is in the map. If it is, we increment it, otherwise we set it. So map 1 is not in the map, so we set the value, set the key as 1, that's the number we come across, and we set the value as 1 because we've only come across it one time. Then we increment, go to the next value at nums1, we're at 2, we check is 2 in the array, no, so we set it with value of 1. We go to the next value in the array, is 2 in the array, in the map, sorry, yes it is. So we know we come across 2 times, so we increment it, and now its value is 2. Go to the next value in the nums1, that is 1. Is 1 in the map? Yes it is. So we increment it, we come across it another time, so the value is 2. Now that's our final map array. Now we have to loop through nums2, and each time we find a number in the map, we set it as a result here, and we decrement the value in the map, signifying we come across that one time. Because this map now represents each number we have and how many times we can possibly come across it. So we start from nums1, the first value of nums2, we check is 2 in the map? Yes. Is it bigger than 1? Yes, which means we can add it to our array. Is it bigger than 0? So if it's bigger than 0, we know we can add it. If it's less than 0 or equal to 0, that means we can't add anymore because there's no values left to add. So we set 2 as it's bigger than 1, bigger than 0, we decrement the value in the map. So now that is 1. We come across it one more time. Now we go to the next value in nums2, it is 2. Is 2 in the array, in the map? Yes it is. Is the value bigger than 0? Yes it's 1, so we add it to the result array 2, and we decrement map. So now value of 2 is 0. Now that is our return result here. So the reason we set the value to 0 is because if we come across a 2 again, now we know 2 is in the map, so we check if it's bigger than 0. But if we didn't check if it's bigger than 0, we'll add 2 again, and the value is incorrect. So the first thing we do is we create a map to store our frequency, so it's a frequency map. Then we create a result array to store our result of common elements. Then we first loop through nums1 array, so let num of nums1, and we set the current number in the map. But if it already exists, then we have to set it, we have to increment it, so we get num. If it doesn't exist, we set it as 0 and increment it. So it's either we increment it or we set it as 1 if it doesn't exist. Then we loop through nums2 of the array, nums2. Then we check if the element in the map is bigger than 0, then we know we can add it to the array because there's still one frequency left from the previous array. So we push value in the array, then we decrement the value in the map. So map.get, map.set, the number as the current value minus 1. So we signify we've already used 1. Then we return the result array. Now let's see if that passes. It does. Let's submit. As you can see, this is the fastest method. This is a time complexity of OM of n, as we're looking through both nums1 as m and nums2 as n, and space complexity of ON, worst case. As worst case, we're storing all values in a long array, which now represents n. Thanks for watching.